Hello and welcome back to another episode about vectors. In this video we're going to talk about vector components. So every vector, the blue vector in this picture, is made up of two separate vectors that are perpendicular to each other. We call those vector components. As you can see, the x component and the y component, when you add both of those together, they end up equaling our blue vector. Any two vectors can be separated into their x component and y component. It doesn't matter what direction they're pointing, how long they are. We can do this to any vector, and we'll find this very useful when we talk more about forces and velocities in upcoming videos. So when we're trying to figure out what the vector components are, we're going to use some trigonometry. So if we look at our blue vector, and we call that R for resultant, if we're trying to find our x component, which we denote by r subscript x, we use cosine for that because Rx is adjacent to our angle theta. So since cosine is adjacent over hypotenuse, that uses Rx and r. Solve that for our Rx and you get Rx equals r cosine theta. Similarly, to find the y component, you'd say Ry equals r sine theta. And you can check this and make sure it's all working using the Pythagorean theorem. And you can say Rx squared plus Ry squared equals r squared. If that doesn't work, you probably did something wrong. It's not always necessary to check that, but if you're just not very confident about a problem, it's a good way to see if you did it right or not. Here's another way to draw vector components. You don't have to draw them tip to tail like we do when we're adding vectors. You can draw them with both of their bases in the same place, as you see here. Both of the green vectors, they're the vector components, are originating from the same location. It's just another way of drawing them. Remember, you can move vectors all you want because they don't have a location. You just can't change their direction or their length. So whichever method you like to draw components in is fine. I prefer the triangle method. It just makes a little more sense to me, but that's just me. You'll find your own way. So let's look at this simulation of vectors on the PhET site. So you can see the URL up at the top if you want to try this out for yourself. The PhET website at University of Colorado has a lot of good simulations which are a bit more visual and make more sense to some people. So here we're going to grab a vector and we drop it here. Let's start it at the origin, and we can grab the end of this vector and move it around all we want. So for the purpose of this video, we're looking at vector components, so let's ask it to display components. So here's one way to display components. You can see a vector on the y-axis and a vector on the x-axis. Those are our two components. And as we drag our vector around, you can see how the components change based on how the vector changes. Now the way I like to draw components is style 2 in this simulation, where it looks like a triangle. And again, you can draw them. You can drag the vector around and see how the components change as the vector moves. So it's always perpendicular vectors are the components. They're never going to be at an angle or anything, no matter how angled your original vector is. And we'll come back to this vector simulation when we do some more addition in a future video. So enjoy your vectors. I'll see you next time.